Hello and welcome to another development update. Today I just wanted to reflect on something very important, and that is flexibility. Okay, so I was designing the cache system and I didn't want to use an existing one like Alembic for a very specific reason, because I think once you bake a file into Alembic, it's Alembic, and the only way to change it is to go back to the program you exported it from, or write another application to manipulate the data and so forth. So it's a bit cumbersome. It's not built into, it's not designed to be, dynamic when you load it into the scene. You can retime it and stuff, but you can maybe change the topology, um, stuff like that, for example. And since there's a lot happening in the background for DeepFX Studio, like the Fluent, for example, there's like the sets. If you've been watching the video and keeping up, there's sets, there's sort of data, there's attributes, stuff like that. So I thought it would be nice if you could record that for every frame. So the cache is actually like a simulation. It steps through and it's got data for each frame. So it record all the attributes, it to catch all the geometry, of course, in a smart way. It's not going to copy the same geometry. It's going to keep it. When it changes, it will update it, so forth. It's not going to update the whole geometry. Everything's been split up into streams, so vertices, stuff like that are referenced separately. So the files are pretty small. So this is an example I was playing with again as usual. So I'm actually working on stuff for start putting up on the website, reels and stuff for when things are ready to be released, and to see if this thing is ready to produce some nice artwork. So this is just a simple simulation, of course, but the cool thing here is the cache. It allowed me to be very flexible. What I can do in the post, for example. So I'll demonstrate one thing. Let's see, just 1 second. Hold on, I'll be right back. Oh, okay, I'm back. I had lost the program, but here it is. Yeah, as I was saying, I was talking about this scene right here. It looks basic, but the process of actually going through and rendering it and creating it was quite interesting. So what I did was pretty much I added if you've been following up, pretty much the new physics system is pretty straightforward. So I didn't touch any nodes for this. For the simulation part, it was pretty straightforward. I set it up, completing the scene, I simulated. So the cool part is I didn't assign any materials or anything like that. So I thought, which was pretty cool. So I assigned all the materials later on through Fluent. So, and I introduced the caching system, which is pretty straightforward. It's actually like a layering system. So the cache, you load it into a track. So you can have multiple tracks, track 1, track 2, track 3. You can think of it like Photoshop layers, for example. And then once you've loaded the tracks, you can actually reference them in Fluent. So you, by default, they're immutable, but you'll be able to change specific attributes like materials, maybe, simple stuff like that dynamically. But if you want, you can actually re-import parts of the cache into a new Fluent scene and manipulate stuff and cache it out again. So you got this in infinite back and forth. And then the cool part is you don't have to simulate everything at once. You can do it in pieces, so you can build up to these massive set pieces, destruction and stuff. You can start adding details and details and details until your computer can't handle it anymore, which is cool. So I'll just load the cache here, which is pretty straightforward. Just point to it and it will load, and then you've got your cache. So let's see, that's actually a bowl for this. Okay, this is the bowl, but obviously it's not in place. That would be around there. You get your so this is, of course, you can scrub these now. So once you've simulated, you can do all this stuff. So I'll show you the cool part. So the renderer will pick up everything automatically, so you don't have to do anything special. You can just add a node, camera, a light, you can position your camera, straightforward, very basic, and then you can render out and see what happens. Yeah, 1 second. Okay, so we've got our beans, no materials here. So only the beans, only the candy in the bowl is in Fluent. Okay, so the bowl is not in Fluent. There's nothing else. I only exported the candy, but there's no materials. Okay, so what I did, which I thought was pretty cool, the material systems are detached from Fluent and DeepFX in general, because one is catered to the visual part, so it's drag, drop, stuff like that, and to be easier to manage and your content like that, So it's more intuitive in that point of view. Then the other one is more intuitive from a visual programming point of view, and more straightforward. So you don't have to link materials to specific to an object or node or anything. So it's just based on a material ID, which you can assign in the material editor. So for example, another thing is variation. So if you can, for example, that's another thing. So technically I could have used Lux Core's got a feature where I can instance all these and assign a unique number to them and add a color, etc. to them. But I thought it was a bit cumbersome because I might add other renderers in the future, and that's not very agnostic. So it would be better to do it in the system, so it doesn't depend on an external feature like that. So that's where this comes in. So just open up an editor. So technically, theoretically, what I'm just going to do is create an override, material override at each frame using Fluent. So I'll just create a flow, add a process, nothing fancy. Okay, and then there's actually a new option here for the track. So these nodes, the track just takes a snapshot of your cache, and that snapshot essentially represents the state of Fluent at that point in time when you cached it out. So all your attributes will be there, and all your sets will be there. So if they're visible, not visible, and stuff like that. So I'll be adding more features. You'll be able to import from those sets and reference those sets. So, but for this point of view, we want to assign a unique material ID to each of these, to the surface of these beans, because there's nothing right now. Of course, you would have done this earlier, before exporting, but let's just say you didn't have time, or maybe you have to change them during production or something. This is a quick way to do it. So simply, we're just going to get the size of the set that I exported. So all you need is the name. So if I remember correctly, it was bullet actor. I'll just copy that. Okay. And let's output an override material. Then I would just need to create a range. So this is where I can assign one number to or one material ID to everything actually. So which is not fun, of course. So I will use a range node. Okay, so I can create random numbers, and I'll put a floor. So we only want whole numbers, not decimals there. And I'm just going to put 4 materials, for example. So 1 to 4. So we have 4 types of jelly beans, for example. Okay, and so yeah, okay, pretty straightforward. And then I'm just going to plug that into the material ID and set which. Oops, that's wrong. Yeah, and set which sets we want to override. Of course, we'll add more override types. Maybe it will be depending on a certain criteria, you can override material there. So this is just the beginning, depending on the situation. I'm sure there'll be more useful cases in the future. So that's pretty much it, just 3 nodes, and we're pretty much done. So we could test this. So to assign a material ID, you just go on output and you give it. So we said that we wanted to generate random numbers between 1 and 4. So this can be any numbers. So whatever your IDs are, you can split them accordingly. So I'm just going to start with 1 there and just give it a value. Let's say there, give it a base color, maybe red, yeah, and just render that out. Yeah, 1 second. Did I forget something? Oh, sorry, I have to actually go to the next frame. Remember, we're using, what do you call this? It's an event, so it says, if I go home, it says starting on the keyframe, so the flow hasn't evaluated. So anyway, that's just as a reminder. So every time you go to a new frame, since this is animation, it makes sense like that. So forgot about that. So yeah, we'll put the other ones here. Pretty straightforward. And green. So yeah, I guess green. And put some blue here. And the last one is the random others as well. And somewhere in there, and if we're there. Oh, I forgot to assign the IDs. Going backwards, it's 4, 3, and 2. Sorry, 2. There goes 5. And 1. So there we go. We've got our colors. We can randomly vary our colors, which is pretty cool. So you can add as many colors as you want there, and you'll be able to do other interesting stuff like that with the caches. Since it persists the data, pretty much what you do in Fluent can be saved out. So which I thought was pretty cool, and which allowed me to create the scene pretty easily actually. So I went through several iterations pretty quickly for this, using that method. Yeah, so yeah, I just wanted to talk about that. So that's the flexibility you'll be able to utilize in your projects. So I hope you enjoyed watching the latest update, and I'll see you in the next one. Thank you for watching.